Right, we're looking at properties of quadrilaterals, and what I want us to make sure that we see here is that there's a much larger group of polygons, which are an enclosed shape. It is two-dimensional, and it has all straight sides. So there are no curves, and there is no opening there. So quadrilaterals are just one type of polygons. There's hexagons, there's triangles, there's all sorts of different things, and we're just looking at the quadrilaterals. So this is a four-sided polygon. So we have kind of three branches, if you will. We have our parallelogram, whose definition is that the sides are all parallel to each other. And then we have some theorems. So on the first day, we proved that opposite sides were congruent. In other words, this. We proved that opposite angles were congruent. In other words, this. And we proved that the diagonals bisect each other. In other words, that. So those are the three things that we proved on the first day. And then the next day, we looked at a specific kind of parallelogram, and that was a rhombus. The definition of a rhombus is this, where we have four congruent sides. And there's a bunch of things that we know. First of all, we know all of these facts. So we have all of these facts repeated, and then we also have that the diagonals are perpendicular to each other. So in other words, this situation there. We have that the diags bisect the interior angles. So that, and that, and that. And so then we go over to this realm here, and instead of all of the sides being equal to each other, we have all the angles being equal to each other. Which are also equal to 90. And we have all of this stuff. We don't have this stuff. We do have all of this stuff, plus the diagonals are congruent to each other. So all of them, whoops, that was not a very good picture, was it? Let's try to fix that. So all of them are equal to each other. And that's pretty much it. Then we get to a square. There's really nothing new about a square. The square is just all these things, all these things, and all these things. So I like to call it a mooch, which is a non-geometric term. But it doesn't really bring anything new to the party. It just steals from all of the other things here. So then we have a kite. A kite is this, where we have two sets of consecutive, congruent sides. And what we mean by that is these are one right after another, and these are one right after another. So that's what we have. These guys here, we have that also the diagonals are perpendicular to each other, just like our rhombus. We have that one set of opposite angles are congruent to each other, so it's kind of like half of my rhombus here. We have one diagonal that bisects the other, and we have one diagonal that bisects the interior angles. So it's kind of like half a rhombus. We've got like this, but then we have half of that, and half of that, and half of that, and all sorts of things there. And then we have our idea of our trapezoid. And with our trapezoid, we've got kind of like half a parallelogram. That the definition is one set of parallel sides, which we don't really get much from but we do get some from our isosceles trapezoid. So the definition is a trapezoid with the legs that are congruent to each other. So two things we get from this guy here. We get that the base angles are equal, and we also get that the diagonals are congruent, and we get that the diagonals cut at the same ratio. Okay, so that is pretty much all we have for this paper.